Thank you for joining our lesson today. Today's lesson is about sound waves. Sound is caused by vibrations, which are quick back and forth movements of articles. So you can see how the sound waves go back and forth and back and forth. And sound is energy in waveform that you can hear. We have how sound travels. If it's traveling through solids, it is fastest, and it would look like this, traveling through back and forth, up and down the scale very quickly. If it's traveling through gas, sound travels the slowest. And looking at our picture of gas particles, we can see it moves much more slowly through the gas particles. So why does it travel faster through solids than it does gas? The particles are closer together. Okay, so it's easier to travel through, and the particles are further apart with gas. Some characteristics of sound being transferred, how it travels. It travels at different speeds through different materials. It transfers energy, and it needs a medium to travel through. Four different things that sound needs to travel: amplitude, frequency, volume, and pitch. So let's talk about those. So amplitude, it is the distance a wave moves from its resting position. Okay? Amplitude, if the amplitude is high, the frequency is high, the volume is louder, the pitch is higher, and the wavelengths are shorter together. Okay, so you can see here on our wave scale, our rest periods. Here are our rest periods. Here is our amplitude, and our wavelengths are closer together. Okay. Frequency. It is the speed of the vibration of the sound. Okay. Frequency is measured in hertz. 1 hertz equals 1 wave per second. And a fact is the average human can hear sound with frequencies between 20 and 20,000 hertz. Okay. Our question, can sound travel through space? No. All right, so let's take a look at our wavelengths here. Our wavelengths are going to be a little bit longer. Okay. All right, looking at volume. Volume is measured in decibels, so D capital B, by a means of an oscilloscope. All right, so volume means loudness or how loud or soft a sound is. Okay, so that's how we're able to hear. So a little danger sign, volume more than 85 decibels can lead to hearing loss. Okay, so all that loud music you have in your ears, keep it down. Pitch, okay, the pitch is the highness or the lowness of a sound. Okay, high voices, low voices, that's where that comes from. So with pitch, the amplitude is low, the frequency is low, the volume is low, pitch is low, and the wavelengths are long. Okay, so long wavelengths. So sound travels in waves, and a wave is a disturbance that moves through particle movements. Waves do not carry particles, but it does carry energy from one place to another. Okay, so here is a medium. Here, medium for wavelength, wave travel, I'm sorry about that, is air. Okay, so let's take a look at this. Here we have wavelength. It's a distance between a point on one wave to the same identical point to the next wave. Okay, we'll call that like the peak even. Okay, and this right here is called the crest, and it's the peak or the highest point on a wave. Okay, might want to add that little arrow that's not quite in your notes on your paper. Okay, so here we have at rest. Okay, and at rest is a position a wave would sit if no vibration occurred. Okay, so nothing traveling, no medium traveling through the air. All right, we talked about amplitude, okay, from its resting point to its lowest point, amplitude here. Okay, here we have higher, here we have lower, so the up and down movement. And the particle movement, the distance at 90 degrees or right angles to the direction of the wave travel. And the wave travel is along this line here. Okay, so time. And here we have the, let me move this up a little bit for you guys. Here we have the trough, okay, this point right here. Might want to add that arrow in. No, it doesn't have to be fancy. And the trough is the valley or the lowest point between two crests. Okay. All right. So now we're going to try this here. And you may want to pause and grab a couple different color pencils or crayons to follow along here. So if our distance is 4 meters, okay, 1, 2, 3, 4, wave travel time equals 2 seconds. So the wave speed would be what? Hopefully you guessed it, 2 meters per second. And the frequency would be 2 hertz. And this wavelength here is just showing you 1 meter. Okay, so 4 meters. 1, 2, 3, 4. 2 hertz. Travels 2 meters per second. And we talked about wave speed here. 2 meters per second. Wave speed is the distance a wave travels in a specific time. And we already said it is measured in meters per second. We're going to do some examples of what these waves look like. So we're first going to draw our example of high frequency wave. So high frequency, you're going to see more. Okay, you are going to have very tall crests and low troughs, and you're going to see more of them. A longer wavelength is going to be spread out over time. Okay, so you're going to see longer wavelength in between each crest. A high amplitude wave is a more, from its resting position, it is going to be higher and longer. Okay, so the space here. A low frequency wave, the sound. Okay, so it's got a lower spot where it crests and troughs off the time. Shorter wavelength, the space in between. Okay, so you can see this example between the long wavelength and the short wavelength. And a low amplitude, a shorter time between its resting position. Last, a high pitch wave has high crests and low troughs, and they're going to be very loud, and they are going to come with more frequency, shorter wavelengths. And the last, so answering this question, a train blows a whistle loudly. What kind of energy is it? Well, we've been talking about sound, so it uses sound energy. Thank you for joining me today.